let's wrap up today by reflecting on what we did to get MaxKey working. So our first attempt at MaxKey, we used the trick from Git where we specify type variables right here that are restricted only to the scope of the MaxKey method itself. Now the issue with this code was that we cannot compare arbitrary whatevers, in this case k's, using greater than. In fact, only numerical primitives in Java can be compared with greater than, though technically because of unboxing you can get away with comparing capital I integers, but not really important right now. The important thing is that k's, we don't know what they are, so we certainly can't say greater than. So our next thought was, why don't we try and use compare to? Now the new problem is that, okay, while greater than definitely is broken, it turns out that k's, they don't necessarily have a compare to method. So the compiler is faced with this code and it says, should I allow this to exist? Is this an abomination upon everything that I believe is a very conservative compiler? Indeed it is. When we look at this this method, the compiler doesn't know if k's have a compare to method, and so we're in some trouble. So we took advantage of a new piece of syntax where instead of just blindly assuming that k's have a compare to and having this error pop up, we instead said, what if k is not just any old k? Maybe it extends something that has a compare to class, or a compare to method. And so in this case, the basic idea is the compiler can say, someone's giving me a k and a v, and I can guarantee, right, that k extends our comparable. So this I know, it's a declaration, a statement of truth about k, that it extends our comparable, and that means that I should be good, because our comparable has a compare to method. Now, the issue with that is that our comparable is not part of this package, and further, strings are not our comparables. So we had to then turn to another interface called comparable. Now this is where it gets a little confusing because comparables, unlike our comparable, actually has a type parameter of its own. So we need to say, I don't just want something that's comparable, I want something that's comparable to other k's. So notice the very subtle distinction. Anything that's in our comparable knows how to compare itself to its own kind, whereas something that's comparable, it could be comparable to k, it could be comparable to many classes at once. And so here the point is that something that is being given to my method, it must be something that can be compared to other k's, so I can compare a k to another k. Okay? I know that's a little confusing, but that's the world of generics in Java. Now the word extends here is a little funny for two reasons. One of them is, isn't this an interface, Josh? Shouldn't it be implements? Okay, sure, maybe. But there's actually another even more important thing about how extends is being used here. This is not changing how k works. So when I go to the top of a class and I do something like, let's say, extends list or something, I'm saying that the map helper class is now going to inherit all the methods of list and whatever else, and it needs to implement all of its abstract methods. But that's not what's happening here. Here the word extends is being used in a totally different sense. It's being used as a statement of fact, not a definition of k. It's not changing how k behaves. So that if k in this case is string, it doesn't somehow make a string that was not comparable now comparable. Are you confused yet? All right, sorry. Now, the word extends here. If I were designing Java, I wouldn't have used extends. I would have said is a subtype of. All right, something like that. And that would be just a guarantee to the compiler that says, hey, by the way, it turns out that k's are capable of comparing themselves to k's, but they happen to use the same word for the action word, the, hey, I declare to the world I am a list, and I can do list things, and here's all the ways that I'm going to do it. Here, the word extends is being used in a, hey, by the way, I'm a list, just so you know, right? So it's the two senses of the word extends. A little confusing. And so, in this sense, it's known as a type upper bound. You are saying, I am a subtype of the comparable interface. Now, this is as deep as we're going to go with generics. I know it's confusing, and you'll have ample opportunity to experiment as you move forward with this class. And I assure you, I'm not going to ask you really insane questions about this because it's just not that interesting, and it's confusing. Okay? So we've now seen 4 features of Java that make generics more powerful than what we saw before. One is the idea of autoboxing and unboxing of primitive wrapper types. Because of those facts, we can write code that more easily lets us slide between different types. We saw the idea of promotion, or, Java actually uses the term conversion. Other languages might use promotion. Promotion means a very specific thing in Java, so I'm slightly abusing the term here. But the idea is we can widen from int to long. we can specify generic types for methods only. And the way we do it is we put it before the return type. That's what this is about, or this right here. And then finally, we have the idea of type upper bounds, which is a subtle one. But it basically says, for the purposes of this method, k extends comparable k. And then if you want, in the optional syntax lecture that'll come 2 more after this, we'll also see some additional types of generic features known as wildcards. And there's actually also type upper bounds as well. Now, I'm going to mention that a true understanding of these ideas, a true understanding of Java generics, it takes a lot of time, a lot of patience, you have to do some experiments, and you're not going to know it all by the end of 61B, and that's fine. And I promise not to ask you questions if you're taking the class for credit about things like bounded wildcards, or type erasure, or covariance, or any of the other crazy things that are in Syntax Lecture 4, and so we'll call it a day right there. But just to give you a little hint of what is in store for you if you decide to look at Syntax 4, and if you really want to learn generics, here's an example of a method signature in the Java standard libraries. All right, see you next time.